All right, everyone, get ready, because today we are going on a journey through time.
Time and space.
Yeah, to a galaxy so old it makes dinosaurs look like they were here yesterday, right?
That's right.
So we're talking about this new discovery,
Sears 93316.
Sears 93316, right? The oldest galaxy ever observed.
That's right.
And of course, this is all thanks to the James Webb Space Telescope, the JWST.
It's amazing.
It seems like every other week it's breaking its own records.
I know. It's unbelievable, right? It wasn't that long ago that GLSD-13 was the oldest.
Right, yeah.
And now Sears 93316 is blowing it out of the water.
So what is it about Sears 93316 that makes it so special? What's the rundown?
We have to imagine a galaxy so incredibly far away that the light that we're seeing from, it's been traveling for almost 13.6 billion years to reach us.
13.6 billion years. I mean, that's almost impossible to even imagine.
It really is. To put that into perspective, if we hopped on a spaceship, right, and we were traveling at the speed of light,
Okay.
which is impossible, by the way,
Right, of course, yeah.
it would take us 35 billion years to get there.
35 billion with a B light years.
That's right. That's how far away this galaxy is.
Okay, I'm trying to wrap my brain around this. So we're seeing this galaxy as it existed
Right. Very close.
right after the Big Bang.
Yes. So this galaxy formed only 235 million years after the Big Bang.
235 million years. I mean, that's practically nothing.
In cosmological terms, yeah, if you think about it, if we condense the entire age of the universe into 1 year, this galaxy is like in the first week of January.
Wow.
That's how early it is.
That's incredible. So it's like we found a baby picture of the universe, right?
Yeah, you could say that.
But instead of a cute little baby, it's like this full-fledged, like already kind of, I don't want to say grown up.
It was well-formed. It's surprisingly well-formed.
There you go, right, for a baby.
Exactly.
So what does this tell us? I mean, how does this change our understanding of the universe?
Well, one of the things that it challenges us to think about is star formation. Because when we see something like this developed this early in the universe, it suggests that stars started forming much earlier than we initially thought.
So our whole timeline is wrong.
It might need some adjustments.
Yeah.
Potentially, it's like, you know when you thought kids were just learning their ABCs, and then you find out they were already writing novels?
Right. No, that's a good analogy, yeah.
It's a little bit like that, where we're like, oh, wait a minute. Things were happening a lot faster than we thought.
So the universe is kind of like a child prodigy then?
It's possible.
It's really making things happen a lot faster than we initially, had thought.
Right. Our models might need some tweaking.
Okay, so early formation, how does that speak to how galaxies themselves were actually, born? Like what's going on there?
Well, it seems like early galaxies were much more efficient at forming stars than we initially realized, and our current models suggest that, galaxies back then were kind of like these small clumps of gas and dust, and over time they kind of merged.
To create these bigger galaxies.
Exactly, just like our own Milky Way, it was probably formed through mergers.
So instead of slowly coming together, it's more like this burst of activity.
It could have been a much more rapid process.
And they're just like full of stars from the get-go.
And that has huge implications for how the universe transitioned from that hot, dense soup
Right.
to this very structured cosmos that we see today.
Okay, now I'm starting to understand why scientists are so excited about this. This is big.
It's a big deal.
It's not just like, oh, cool, we found a new galaxy. This is like paradigm shifting kind of stuff, right?
It has the potential to be.
But how did we even find this galaxy? Like, how did this even happen?
So this is actually kind of a happy accident, so to speak.
Okay.
A team at the University of Edinburgh,
Okay.
they stumbled upon it.
They weren't even looking for it.
They were not.
What?
They were looking at data from the James Webb Space Telescope.
Wait, so they were just looking at other stuff and this just popped up. Tell me everything.
Yeah, so they were studying the light from even more distant objects, and they were using this technique called gravitational lensing.
Gravitational lens. Okay, that sounds complicated. Break that down for me.
So it's kind of like a cosmic magnifying glass,
Okay.
where you have these massive objects, like galaxies, that can actually bend the path of light that passes by them.
What?
Yeah, so the light from these even more distant objects gets bent and amplified by the gravity of a galaxy cluster that's closer to us.
So it's like this closer galaxy cluster is helping us cheat so we can see things that are even further away.
Exactly, it's giving us a boost.
Okay.
And as they were looking through this magnified light, they spotted the faint signature of Sears 93316, just hiding in plain sight,
Wow.
just lurking there.
It's like finding a message in a bottle that's traveled across like a cosmic ocean to reach us.
It's a really good analogy. And you know what's even more exciting?
What's that?
This is probably just the tip of the iceberg.
Okay, now you're getting me really excited. What else could be out there? What else could we find?
Well, if we're already finding galaxies like this so early on, it makes you wonder,
Yeah.
how much earlier did star formation, galaxy formation actually begin?
Right.
Were there even earlier generations of stars and galaxies that we just haven't seen yet?
Generations of stars. We haven't even seen a single one.
Yeah, that we haven't even glimpsed, yeah.
It's mind-boggling.
It really is. It kind of makes you feel small, doesn't it?
It really does. It makes you realize how much we don't know.
Absolutely.
But okay, let's say we do find those even earlier galaxies. What does that change? Like, what does that actually do for our understanding?
Well, those early galaxies would have played a crucial role in shaping the universe as we know it.
Okay.
For example, they were likely responsible for producing the first heavy elements, the building blocks for, well, everything, planets, even us.
So we owe our existence to these ancient stars.
In a sense, yeah,
Wow, that's amazing.
because they created the elements that make up our planet, our sun, even our own bodies. You know the saying, we are stardust.
Yeah. Yeah.
It's literally true.
I've always loved that quote, but it's different when you really think about it.
It takes on a whole new meaning, right?
It really does. Okay, so understanding those early galaxies helps us understand where everything came from.
It's like looking back at the universe's baby pictures.
But what about the future? What about where we're going? I mean, does this discovery tell us anything about that?
That's the million-dollar question, isn't it?
Yeah.
And this discovery, it throws a bit of a wrench
Okay.
into our cosmological models
Mhm.
because it suggests that things might have happened much faster
Right.
and more efficiently in the early universe than we previously thought.
So where do we even go from here? Like, what are the next steps?
Well, the James Webb Space Telescope
Of course.
is going to be crucial in pushing those boundaries even further.
It's like we just opened up this cosmic treasure chest, right? But what are astronomers really excited about? What are they hoping to see with JWST?
One of the most exciting things is the possibility of directly observing the very first stars that formed after the Big Bang.
Okay.
These are called population 3 stars, and they would have been massive,
Okay.
short-lived, and made entirely of hydrogen and helium.
Wow.
And their light holds clues about those very early conditions of the universe.
So we could actually witness the birth of the very first stars.
We could,
Yeah.
potentially. That's the hope.
That's amazing. So we're looking back in time, but we're also learning about how galaxies themselves evolved.
Exactly, because one of the key things that we're learning from observations of Sears 93316
Okay.
and other distant galaxies is that galaxy mergers
Okay.
were a major driving force in the evolution of the universe.
So those smaller galaxies we talked about earlier, they weren't just sitting there, they were bumping into each other
Yeah, they were constantly interacting, merging.
and creating these bigger galaxies.
Exactly.
Wow.
And those mergers weren't just random events. They played a crucial role in shaping the properties of galaxies.
Like how?
Well, they influenced their size, their shape,
Right.
even their ability to form new stars.
So our own Milky Way, this beautiful spiral, it's the product of all these ancient collisions.
Most likely, yes. And it's still evolving, still interacting with its galactic neighbors.
Wait, really?
Yeah. In fact, we're on a collision course with the Andromeda Galaxy.
We're going to collide with another galaxy.
We are, but don't worry, it's not going to happen for another few billion years.
Okay. A few billion years, I won't lose any sleep over that.
And when it does happen, it won't be a catastrophic event like you see in the movies.
Okay.
Galaxies are mostly empty space, so the stars within them are unlikely to actually collide.
Okay, that's good. That's good to know. But still, the idea of galaxies just merging and reshaping themselves, it's mind-blowing.
It's a reminder that the universe is this dynamic, ever-changing place.
It really is. And as we continue to look deeper, I mean, we're just going to find more and more and more stuff.
No, absolutely. We're just scratching the surface.
I mean, this whole conversation has just been, it's a masterclass in cosmic perspective.
It really is.
It makes you realize just how much we don't know and how much there still is to learn.
And that's the beauty of science, right?
Yeah, that pursuit of knowledge, the thrill of discovery. I mean, it never really gets old.
It doesn't. And with tools like the James Webb Space Telescope, the future of astronomy is really bright.
It is. It's a great time to be an astronomy fan, that's for sure. But you know what's really cool about all of this?
What's that?
It's not just up to, scientists to make these discoveries.
Okay, neat.
So the way that team stumbled upon this galaxy, it actually highlights something really cool about modern astronomy.
Okay.
The James Webb Space Telescope team, they're committed to open science.
Oh, I didn't know that.
Yeah.
That's fantastic.
So they make their data public.
Wow, so anyone can access it.
Anyone.
That's incredible.
Yeah. So anyone with an internet connection and, a passion for this stuff could potentially make the next groundbreaking discovery.
Wow, that's amazing.
It's true. The data is out there. It's just waiting to be analyzed.
That's so cool. It's like democratizing science in a way.
It really is. And this discovery wouldn't have been possible without the James Webb Space Telescope.
It's true.
I mean, it's like we have a time machine now. We can look back billions of years.
It's incredible, isn't it?
It's amazing. And to be able to see, the universe in its infancy, essentially.
And, JWST's ability to detect infrared light is
Yeah.
key.
Okay, why is that?
Because as the universe expands, the light from these distant objects, it gets stretched out.
Okay.
And this is called redshift.
Redshift, right?
Exactly. And the further away an object is, the more redshifted its light becomes.
Okay.
So by the time the light from these incredibly distant galaxies reaches us, it's shifted all the way into the infrared part of the spectrum.
So that's why we need JWST, because it can see
You can see what we can.
the invisible.
Exactly.
Wow, that's amazing. But even with all the amazing technology, it still comes down to people.
Of course, the scientists who dedicate their lives to this.
Right. I mean, what is it about these mysteries that just completely captivates people?
I think it's that human curiosity, that desire to understand our place in the universe.
It's a simple question, but a big question.
It is a big question, and it's about pushing the boundaries of human knowledge, exploring the unknown, and inspiring future generations to do the same.
And that's really what it's all about, isn't it?
It really is.
So as we wrap up our deep dive into this amazing discovery,
Sears 93316.
Sears 93316, what's the one thing you want our listener to take away from all of this?
I think the biggest takeaway is that we are living in a golden age of astronomical discovery.
We really are.
With tools like the James Webb Space Telescope, we're making incredible strides, and this discovery is just one example of the amazing things to come.
It's true. It feels like we've just embarked on this incredible adventure and we're just getting started.
Exactly. The best is yet to come.
I love that. The best is yet to come. And on that note, we're going to take a quick break, but don't go anywhere, because when we come back, we'll have even more on the incredible discovery of Sears 93316, the oldest galaxy ever observed. It really is. Every time we answer one question.
And 10 more pop up.
Exactly. It's like
Yeah.
it's like the universe is this giant tapestry, right? And we're just now starting to see like the intricate
And
pattern.
we're just starting to understand the threads that connect it all.
Right, exactly. And the best part is we're not just, sitting back and watching.
We're active participants in this cosmic drama.
We are. We have the tools. We
Yeah.
have the brain power to figure out what's going on.
To unravel the mysteries and really piece together the story of our cosmic origins.
It's incredible. So the next time you're outside and you look up at the night sky,
Take a moment.
take a moment, because those twinkling lights,
They're not just distant suns.
there's so much more to it.
They're echoes of ancient events, whispers of creation, destruction,
Stars being born, galaxies colliding.
all across these vast distances
Mm.
that are impossible to really even fathom.
It's incredible. And somewhere out there
Hidden in that faint glow of the early universe
are the answers.
to the biggest questions we have.
Where did we come from? How did it all begin? What is our place in all of this?
Keep looking up.
Keep looking up. Keep asking questions.
Never lose that sense of wonder.
That's fantastic advice. And on that note, I think we're going to wrap up this incredible deep dive into Sears 93316, the oldest galaxy ever observed. Thank you so much for joining us. And until next time, keep exploring.